Welcome to the March 2025 GoldSim webinar. So today I'll be talking about time series imputation, filling in the gaps, filling in data for missing values in time series. I'll be presenting 4 different strategies, and each of them have their strengths and weaknesses, I guess. They're all very different from each other. So what I'm hoping here is that at least, these might not be very new concepts to a lot of you, but at least you'll have an idea of within the GoldSim framework how you might approach some of these. So to begin with, I will be describing in very simple terms how the time series element in GoldSim can deal with missing values just using its built-in functionality, and just talk about some of potential pitfalls that you could run into depending on how you might set it up. Okay, so here we're looking at a chart of precipitation, and if I were to compare this to temperature, and I just grabbed 25 time steps from some existing data. Precip is on the left and temperature is on the right, and that's shown in the blue line, the temperature. So obviously these are very different types of information. One is highly variable, oftentimes at 0, the precip, and then the temperature is fluctuating, but not as much. So having that information is helpful to know maybe different strategies that you might apply to either one of these if you're missing data. So if you're missing, only very short periods, maybe you have 1-day time steps in your time series and you're missing 1 day here and there, maybe it's fine to just assume that the value is 0 if it's missing, for precipitation. If it's a very, small number of those. You could also, with temperature, look at just using the interpolation methods that are built into the time series. So let's explore what happens when we do that. And I just randomly picked a period of time from a time series here, but you can see with the precipitation, we have this big spike on this 1 day. So what I was looking at is, well, what if, and sometimes what happens is, the equipment that's measuring this information might have a problem during a storm event, when something big is happening, like a rainstorm. And so sometimes you're missing data right after a big, large number like this. And so what if that happened? What if we look at a situation where we are missing rows right after a large event? So here we have, and also I've simplified this time series. It's not showing dates. Typically you would show dates in your time column, right? But just for simplicity, I'm I'm just showing elapsed time here in this, or I just changed the dates to show elapsed time. And you can see here we're missing day 17 through 20 between these two rows that I'm highlighting. So I've removed the rows there. So the question is, what do we do? How do we interpolate, or how do we fill in for those days when we're running a simulation for that period of time? So that the options that we have in GoldSim, let me go back to edit mode. The options that we have in GoldSim are here where it says represents. The default is instantaneous interpolated. There's another one, constant value over next. I'll just be focusing on these two for now. If we said instantaneous interpolated, then essentially what that means is it's going to linearly interpolate between 32 and 0 between all those days. So, so running the model then produces this blue line where the real data was this red line here. So you can see we would be very much overestimating rain during that time, and even more so if we used constant value over next. And with the temperature data, it's not so bad, not as bad, but we got lucky in this case. I looked at a case where we are missing the same exact period of time, and it turns out that linearly interpolating actually, just by chance, matches quite well with the data that we removed. You can see the red compared to this blue here. Constant over next would just hold constant. That's this green line until we get to the point after the missing data. So I'm just pointing out here that missing 1 or 2 days here and there may not be a big deal, depending on whether you're using constant over next or interpolated. But in other cases, it could make a significant difference. And I have seen this multiple times where you pulled the data, you get maybe the data from maybe a website or something, and it looks good, but maybe I didn't, maybe I wasn't careful enough to analyze the entire series to see, how many days are we missing? Are there any periods where we're missing, more than 1 day? And what are we assuming for that? If you assume constant over next, something like what we're showing up above, then you would grossly overestimate precipitation in your model and cause some, problems downstream in the model. So I just wanted to point these two methods out. So the question might be, well, then how should we deal? How should we deal with this kind of a thing? So I'll be talking about some other strategies next, but I did want to just make sure you're aware of the abilities that are built into the time series and what it does. Now, I did also mention that, maybe you could, like in particular with precipitation, because it's so often, or if it's a dry or arid location, maybe it's more commonly that you see no rain, then assuming 0 could be, I guess, considered conservative, perhaps. So that's something to consider, that you could replace missing values before you put it into GoldSim. You just replace missing rows with having the interpolated or the inserted date with a value of 0. Could be an option in that case. Okay, so yeah, once again, with data that is perhaps trending and not so variable as precipitation, linearly interpolated could work okay in a lot of cases. But sometimes, if we were missing, say, for example, days 10 through 13, a linear interpolation would just chop off this whole, area where the temperature is rising and miss all of that. So interpolated in this case may not be so good either. Now, also, I just wanted to mention that the methods that I'm proposing here aren't necessarily a magic bullet either. It's not like we're just going to magically know what happened in all cases, but there are things we can do to help with that. So the next thing I want to talk about then is spline interpolation. Okay, so here's a model, and this is on our website, and I can point it out to you at the end. But this uses the DLL to calculate a spline interpolation, and it does require that you modify the time series ahead of time. So what I mean by that is, if you have missing rows in your time series, that you must fill in all the rows so that all of the incremental steps between dates are the same. You don't want to have any missing time values. And if you have missing values, they need to be replaced with a missing value code, a numeric code. In this case, I'm assigning a -999, and that's something that you would assign to the model here in this data element, but that also means that missing values in the time series must also have that same code, -999 in this case, in order for this function to know that, okay, that's a missing value I need to interpolate. And this model also requires that you have a DLL that is alongside this model in the same directory. Well, it doesn't have to be in the same directory, but you need to specify the path to it. In this case, it's a relative path, meaning that this DLL is located in the same directory as this model file. So if you look at the interface to the external element, you'll see that we give it the time series definition. So that's something I need to make clear with a time series. There's two different outputs of a time series. There's the instantaneous value, which is just the single output at any given time during the simulation. And then there's the definition, which is the entire data set. It's the entire time series. That's what the definition is. So it's really important to understand the difference between these two outputs of the time series element. And the DLL, if we go to the interface, it is linking to the definition. So it's taking the entire time series definition all at once and consuming that completely, running that through, it runs that through the function, and then it brings back at each time point the value. So it takes this information in at the beginning, and then as we walk through time, it will then output the values at each time. Okay, so when I run this and then look at the output, then what we have, we're showing here 3 different locations where we're missing information. And so you can see it's interpolating in what feels like a smarter way to interpolate than just a linear, just straight across interpolation. So what I mean by that is if I zoom in, then what you'll see here is that it's using a spline interpolation, right? So it's making it more of a smooth transition instead of just a straight line. So this could be useful for somewhat short periods of missing data. I would say once your data is once you're missing a bit more information, in this case, this is only 4 days here. So if it's much more than that, it could be problematic. And so just keep that in mind. If you're missing more, 10 days or more or something in this type of a time series with this much variability, then it would start doing things that are probably not so good. So for example, it's going to be looking at the slope of the previous couple of time steps, and then the slope afterwards of the missing gap, and then it will do projections based on that. So if you could have a large swing up or down if you're missing a lot of points, and you'll have to play with this a bit to see how that could work for you. But just be aware that when you're missing a lot of values in your time series, that the spline interpolation could start to give you values that are not going to be very realistic. Something to keep in mind. Okay, so that is spline interpolation. The next thing I want to talk about is doing a regression analysis, and this does involve a lot of Excel work. So I'll walk through the steps briefly. Maybe it's just a review for a lot of you that maybe do this all the time. For me, it had been a few years since I'd done this, so I had to refresh my memory on how to do all this stuff. So I'll just walk through quickly here. What I have is 2 locations. I have a streamflow measurement site that I gathered data from the USGS water data website. And on that website, you can view a map where it shows point locations of where they are measuring discharge at various stream locations. And I have this one location that I wanted to look at, but it's missing an entire year right in the middle of this time series. Not only that, it only has a fairly short amount of data, but at a nearby location, this other one called Rex Creek, it's a larger creek, but it's close by, and the data is a lot better, and it's also not missing the values for the same year. So this would be a good candidate because it's got a lot of really good data. And you can see that once I've lined up the time series, and that's also a very important step of this, is to make sure that you line up the time series exactly on the date. So you have to put them side by side. If you're missing any values, you have to remove those from both time series, right? So then you have to scroll all the way down, check, spot check the dates, make sure everything's lined up all the way down. And once you have that all set up, then you can run the analysis, right? So in Excel, you just have to make sure that you go to File, Options, and then go to the add-ins and make sure that you have the analysis tool pack if you're going to use the built-in function for regression analysis in Excel. So enable that. And then once that's on, then you go up here to the Data tab, and you'll see there's this new Data Analysis button right here. You click on this, and then scroll down to Regression Analysis, and then you just click OK, and then you put your 2 columns of data in for the Y and the X. And in this case, in my case, X is the Rex flow data set, just the numbers, just the flow numbers, and then Y is the Boulder Creek data. So, whoops, I need to just cancel it. So I already did that, and when you run that, it puts all this information right here wherever you click in a cell. So I clicked right here and I put all this information here. It does show you regression statistics indicating how well they correlate. And you can see here that with this factor, the multiple R factor, you can see that we have a good correlation between these 2 data sets, a fairly good correlation. And the 2 numbers that we want to look at is the intercept and the slope, and that's these 2 factors right here. The intercept being this first one, slope the next one, and we're going to be using an equation that will allow us to reconstruct the missing values for the Boulder Creek. So let's say we're missing this value right here on March 20th, 1983. If we're missing that value, then the equation for that would be essentially it's Y equals A plus B times X, where X is Rex Creek. So to do that, then we would say it equals A plus B times Rex Creek. So I said March 20th, so this one, enter. So it says 13.3, so that turned out to be pretty close. Now, one problem area might be, and it does happen, you see that the intercept is negative. So if we get into a situation where Rex Creek is a very small number, then we run into potentially a problem where we have a negative value. So let's say that Rex Creek is, something small like 1, then we get into a negative number. So as far as when we're building this in GoldSim, then we'd want to put a max function in here just to prevent it from going negative in those few cases where Rex Creek is low enough. Okay, so this is something you kind of have to just do in Excel first. Definitely you have to go and clean the data and get these 2 data sets to be aligned by their dates. That's for sure something that has to happen before we are ready to use it in GoldSim. So let's move over to GoldSim now. Now in GoldSim, we can do a regression analysis too, but it is very important that you have the 2 data sets cleaned up and ready to go first. Now, I couldn't really think of a good reason why you'd want to do a regression analysis first in GoldSim. I mean, there could be a situation, perhaps, maybe you have, maybe you're calculating a couple of maybe time histories, and you want to do a regression analysis of those 2. I can't really think of a reason. Perhaps there is one. And if there is one, well, the important thing, once again, is to just make sure that you have the two data sets aligned. And the best way to do that, I think, the safest way, is to use a data a vector instead of a time series. The reason I would avoid a time series is because the issue with time series in GoldSim, well, not issue, but just because the way time series work in GoldSim is that if you're missing any rows, now what I mean is if you're missing dates, then GoldSim just interpolates. And there's not really an easy way to just, like you would with an array, you can't just do a for loop and just walk over each of the values. I mean, you can do that with a time series, but if you have a gap in the dates, it will just continue to walk through the missing dates as if they exist with interpolation. And that's not what we want. What we want is just, we have this table of numbers, right? We don't really, in the case of regression analysis, we're not really looking at the dates. We're just looking at the two arrays side by side, right? And so that's really the safest way to do it. So if you have a time series where you do have continuous constant time increments where there is no gap in the time, then it's okay. Then you could do it with it. You could have this as be a time series. And where I'm getting at is, in the case of, if you have a model where you're calculating two outputs that are time histories, they're varying through time, and you want to do a regression analysis of those, as long as the time points are all equidistant, then you could put them together in here and walk over them the same way I do with the script element to do a regression analysis to get the intercept and the slope. So anyway, what I did is I just grabbed these columns of numbers and I put them in a data array. So here you can see Rex Creek right here, the X value, 78, starts with 78, and it goes all the way down 15,000 rows and more, or so. Okay, almost 15,000 rows all the way down. And so that's a really big array, and that's going to be a very expensive operation if you are iterating over all of those values every single time step. So that's another thing we need to think about. And so that's why I'm using a script element here. So let's just take a quick look at this. With a script element, I'm grabbing the X and the Y arrays right here. And then I have my variables that are used to do the regression analysis, essentially taking sums of them and sums of the two multiplied together, and etc. But the important thing here is that we have an if statement that limits our algorithm to only be running at a certain time. And I said when e time of the simulation is 0 days, then we'll go ahead and run it. And here's the for loop, and the for loop will walk over all of the items in the array and do the calculations and come up with the slope and the intercept. And a very important part of this is, because we are only executing this at time 0 and we want the value to be available for the entire simulation, then it means for the script element, we need to assign the values we're looking for to the result. The result is the output of the script that can hold its state over time. So all the other variables in here, they always refresh every time step. They don't carry forward in time. They always re-update, reinitialize every update. But a result is different. The result is the script itself, and it operates just like other state variables in GoldSim, like the pool element and the reservoir and the integrator and the status. Anything in GoldSim that carries state forward, remembers what it had on the previous update, you'll know it's a state variable in GoldSim if it has an initial value. Anything in GoldSim that says, what's my initial value, you'll know that's a state variable, and that can carry forward memory through time. And that's what happens with the script element. You can see up here, it says initial value. And you'll also see that I have two values. This is actually an array of two values. And I did that because I'm looking for intercept and slope outputs. And So if you go up here to the array label sets, you'll see I've already defined my a new array label set called regression that gives us intercept and slope, just two numbers. I had to do it this way because that's what happens in a script element. If you want to carry forward the state of two or more than one output, then you need to make the script element be an array. This is actually super useful, by the way, if you're using the script element to do things where you want to keep track of multiple variables that carry state forward. It's quite common, actually. And a nice thing about that is that you can just use a vector, and for whatever kind of problem you're working on, if you want it to carry its value forward to the next time step, then you would just assign whatever item within this vector to be that variable. And so that's what I've done down here. You can see down here, we get down here to B, and B is the slope. And I've assigned the second item of the array of result to that value B at the end of my for loop, but not outside of the if statement. So what that means is at time 0, we assign it, and then it's forever going to stick afterwards because I don't assign the result to anything else afterwards. And then I do the same thing for the first item of the array. This is the intercept. I just assign it directly, the intercept right there. And then once that's done, then we can run the model. And what you should see here is that when I hover over this element, you should see that we have the same values, which we do, -2.5 and 0.27. You can see that matches over here what we got in Excel when we ran the regression analysis over here. So, so now we have those values immediately. And like I said, typically this is not something you would do in Excel. So this is a one-time thing. Anytime you have just a one-time thing that you need to calculate like this, I would say it's probably easier just to do it in Excel first and then just have them as, constants. So we could just then change this to a constant. And by the way, in GoldSim 15, now you can immediately transform an expression to a data element, right? So then we could just wipe that out and put in -2.5, etc. And then use that. I could have done that with this one, but I didn't want to change it. So anyway, that's something we can do now. Anyway, now we come over here, and now that we have the intercept and the slope, we can build the reconstruction equation, which is essentially A plus B times X. So intercept, and notice I've had to cast units because the regression analysis is a unitless function. In my case, I'm dealing with cubic feet per second. And so I have to cast the units on to this unitless number, CFS, and then multiply slope times Rex Creek here. Rex Creek happens to be already in CFS. And then I put the max function. So just to make sure we don't have any negative numbers. So now that I have that reconstructed time series, now all I have to do is find locations where we're missing values in Boulder Creek. And then I can run the model. And you see it runs pretty fast, and it does run fast because I've only done the regression analysis at time 0. If I had run that every time step, it would have taken a long time to run this model. Okay, so now we can look at the chart, and you see the green line shows us that we are reconstructing only the period that's missing, because in this time series I put in there I put in a negative number to indicate a missing value. So that's another important thing you have to do. In this time series, if we scroll down to the area where we've got missing information, let's see, I think it was 2000. I put the codes missing. There we go, right here. So you can't just remove the value. I mean, I could have removed the values. We could just say put this one number right here, September 30th, 2000, with that number, and then we could have just deleted all of these rows until we get to the other end right before and put another -99. That would have been the same thing. But it's important that you have those delineators in here before you run the model. You can't just have missing rows, right? Otherwise, it wouldn't know if it's a missing value, because we use a selector element here, essentially an if statement. Whoops, we use an if statement here that that says here that if Boulder Creek is greater than or equal to 0, then we know it's good. So then we're just going to use it. Otherwise, we use the reconstructed values. Okay, so what are some benefits and drawbacks to this method? So this method is good in that it will represent well the area that's missing relative to what the other site experienced, which was nearby. So it should, if it was a dry year that year, then we would be imputing dry year data, which would make sense. But it is very much tied to exactly what happened over there. So it could be, that it's a little bit, slightly different in some cases, not exactly the same. And if we were to, compare the reconstructed to Boulder Creek, it wouldn't match all the time exactly. So there's a little bit of error, but again, our correlation is pretty good here. So we're going to get a pretty good representation in this case. Okay, so that's using regression analysis. The next option that I want to show you is using a stochastic model to impute the missing values. So this one is a bit more involved in that you first have to build a model that you can represent this information. So what I'll be showing you is there's a couple of models that we have on our website. This one that I'm using right now is this simple Markov process precip simulator, and this is on our website, and it comes with a model that you can use to generate the parameters by analyzing the historical record, your historical time series. So you might be missing some values in it, but whatever you can get, try to find a solid amount of period of time within your time series that's continuous to put into this model that generates parameters that then can be used to stochastically simulate those missing periods of time. So it will be seasonally and day by day representative. It will represent well based on the average of what it found in your historical record. So let me show you what that might look like. So here's the model. We have this precipitation data here. There are some missing. I think it's just missing the same amount of time right around the year 2000. There's a period. Let's see, 9. I think it's over a year that we are missing here. Well, anyway, we're missing about a year right around 2000. And so if I open it here, you can see, oh, it's right around, okay, it's 2002. So the period that we're missing is, I have this little green dot at the top here that indicates we're missing data. And you can also kind of tell we don't have this background red line underneath the blue line. There's a couple of spots over here too. But this is the main period that we're missing data. The nice thing about putting a stochastic element in here is that, let's say we're trying to represent the future used by sampling our historical record. But if we're missing this big gap right here, then we'd want to put something in there that would be representative. And this is representative historical record, but of the entire historical record. So if I run this for multiple realizations, and you can see as I flip through these, you can see that on each realization, it's using random numbers to come up with a precipitation time series that it pulled from the historical record. But some years some realizations are different because they are random, but they are historic, or they are seasonally relevant because of the way that it looks at the historical record. And then you could also look at, if we looked at the probability chart, then you can see here that we're using the same historical record, but when we get into the period, the zone of missing values, then you can see here we're, in this case, it's just indicating here that we're sampling many different possibilities for all of the different realizations. And so it can allow us, it can provide us a way to represent possibilities that are, different, but still realistic and relevant. So there are a couple of tricks with this that you have to do. You have the time series itself, and then you have the Markov model that I put in here. So you first have to build the Markov model. The Markov model requires that you have input parameters, and that's really just this set that looks like this. You need these input parameters to run this model, and that's what that other program does that you can download. It's called Parameter Generator. You just feed your time series into it, and it will generate these parameters. They're just these seasonal parameters for probability of wet versus dry and how hard it rained with the alpha and beta. So once you have that model built, then it would just be a matter of determining whether or not you're missing values or not. So that's, again, where you need to pre-process your time series and make sure you put in some sort of numerical indicator of a missing record. In my case, I'm using a negative number, -99, to tell the model, okay, we're missing values. Therefore, you need to switch from historical record to using the Markov model output. And we also have on our website, we also have the same thing for temperature. So we have this model here, this temperature simulator. It does a similar thing. It randomly generates temperature, and you build the model in a similar way. You find your historical time series records, you put it in, and it calculates these model parameters that then you can use to simulate periods that you have missing records for temperature. You could do a similar thing for a wind model for doing things like calculating whatever might be evaporation or something. So this is just another way to represent and impute missing records in your time series. Okay, so I don't have a model to demonstrate. I mean, I could demonstrate doing it with temperature, but you'll end up with a similar type of situation as what we were seeing with the precipitation model. But in all of these cases, they all kind of depend on your particular type of situation and how you might want to deal with missing records. But hopefully with these 4 different methods, you kind of have an idea of the level of complexity in building them. And so that's all the presentation, but I'm happy to answer any questions that you might have. And if you don't have any, thank you for joining, and hopefully we'll see you next month. Somebody asked where you used the script and ran it e time equals 0. Could you have also done that in a submodel and ran that at the beginning? That is a good question. I think that's perhaps where I started when I first started looking at this problem. But I chose instead the script because I think I just chose the script because of in this particular case, because I'm just dealing with a couple of arrays. At first, I was starting to go down the path of using a time series definition, but then I was worried that we might get into situations where we're missing some dates in the time series, and that would kind of mess it up. So I wanted to avoid because it's really easy to work, with a time series definition in a submodel. But other than that, I mean, yeah, we could have easily done the same thing well, wait a second. I think the script is better. I think the script is better in this case just because it's a simple for loop. And but yes, we could have done this in multiple ways, I suppose. We could have, as long as the time series had continuous equidistant time points, then yeah, we could calculate all these things. Yeah, that's true. We could have calculated all these things just with regular, just like some integrator elements inside of a submodel. Yeah, and then you could trigger it to run at time 0, and then output the same thing. That's true. You could have, but the submodel is a lot more complicated, a lot bigger of a thing, and the script element is just kind of more like lean and mean, I guess, and just pretty simple to document as well. I could just print this script and just maybe like edit it a little bit, throw it into a document. By the way, the script elements are also kind of nice because a lot of times, like if you're using AI to help you, document a larger script like this, then it can very easily read and understand the printout. And it prints into PDF, but it's really easy just to select the text, just grab it, copy and paste it. And so there are some benefits there as well, I think, with the script element, just making it a little bit easier to document. So that was a good question, though. All right, it looks like I don't have any other questions, so I'll go ahead and close this down. Thanks a lot for joining. See you next month.